Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Mr. Siva Subramanyam Mantha, and he will talk about technology intervention in today's farming. I now request the speaker to begin. Thank you.
Thank you, ma'am. Good evening, everyone. My name is Siva Subramanyam. I am the CEO of Plenti Farms Private Limited, a Bangalore-based agri-tech company. Thank you for providing this opportunity to me to speak about technology intervention and its impact in farming. I would begin by trying to introduce how we have been seeing farming happening for the last centuries. The traditional farming method is limited to preparation of soil, sowing of seeds, adding fertilizer, irrigation, weed protection, harvesting, and storage. The knowledge here is transferred from generation to generation with not much of an improvement or an adaptability to the changing situations today and the changing variable issues that we see out in the market or in the field. It is pretty historical as a practice, so we can always call it tribal knowledge. It's passed from generation to generation. My grandfather did it this way, my father did it this way, and probably I also do it the same way. The knowledge too is pretty localized. There is what works in a particular area or a zone does not necessarily work in some other area or some other zone. There is minimal ability to adapt to the changing situations or the way the farming should adapt to climate change, to different types of seeds, fertigation methods. It's not conducive to adapt to these sort of variables that are now emerging. The output also is not very predictable. We all know that the farmer continues and carries the risk throughout the life cycle of the farming cycle. Uh, Across the value chain of from farmer to retail or consumer like you and me, the risk is always with the farmer. And like I pointed out in the localized knowledge point, it serves a very small geography. Its ability to try and be replicated in any other zone is very limited. I Before I move to agriculture and how it has progressed, I thought I could bring about the corollary from manufacturing sector. We all have seen manufacturing very closely. At least as a consumer, we have consumed a lot of products that are there. Manufacturing was earlier done in a garage or in a small shed, but in the early 1800s, industrialization actually brought manufacturing under a single roof. And as we progress into the 19th to 20th century, I would say a lot of mechanization in the form of machine tools and electrification of production lines led to consistent production, predictable production. The next stage that we actually saw was of automation, which was brought about in the 1990s. We all know about Japanese automated manufacturing, robos. PLCs are programmable logic controllers, and a lot of electronics. This was more to run it like a process rather than true manufacturing. And the last but not the least, as we moved into the 2010s and probably the last decade and more, we've seen a lot of convergence, which has rendered manufacturing a very highly specialized set of processes. The tools that are now being used from SCADA to cloud computing to AI and ML. For the uninitiated, AI is artificial intelligence and ML is machine learning. So it was not a big surprise that what was successful for manufacturing was being replicated for other areas. We have seen this in logistics today. We've seen it in the food business. We are now seeing a similar uh, acceptance in terms of trends and automation in farming. Traditional farming, like I said, we've seen a lot of traditional farming across. When we drive on the highway, the methods are pretty simple. What I know, I do. Mechanization brought in an aggregation in the form of harvesting to tractors, even to a certain extent, even some level of processing, dehusking of rice is one of the classic examples there. The 80s brought in some level of automation, but that level of automation was more at the other side of the farming life cycle, which was more with the processors. And And what actually transpired from there till 2000s, I think a huge adaptation of precision farming started coming in. As we go into the future slides, I will be explaining the precision farming and what are the smart technologies that are being adapted across the world. And India should not be very far away in adapting these, as some of them make very good sense in terms of the value of production that we do. For the just for the record, we do close to about $450 billion worth of agriculture and fisheries. These are some published numbers from Government of India. So the type of potential that precision farming and smart technologies could really bring in is very high as we go forward. What is precision farming? Precision farming is very pinpointed farming methods which uses a lot of data, technology, and automation, and an ability to correct itself or propose new data points or new interventions as it learns more. Finally, as an objective, of course, it should lead up to sustainability. So the tenets of precision farming today is a data which drives a lot of decision making. It utilizes data from managing crop cycles, feeding into a typical computer set or a program, geotagging and geofencing, so that a lot of the information is localized and can be replicated over a larger area. Uh, and in data, of course, the most important elements that can capture data using IoT. IoT is Internet of Things, which I showed in the manufacturing slide, and spectral imaging and manual feed of data also is something that has been helping get to that data set. The next stage for this is the technology intervention using automation, using GPS, sensors, and a lot of drones. Drones are not only meant for typical spraying but also for hyperspectral photography, getting crop signatures, soil signatures. In some cases, we have also seen LiDAR being used as a technology to try and map the complete terrain of a farm, village, district, or maybe a big state. The government of India and multiple states have also invested in these technologies and have started the work of digitization and trying to bring multiple set of data under a single intervened technology. The ability of continuous improvement is something that will define how well we are able to use this data. I call it the learn and improve. Analyze data regularly, manage processes and yield, and ensure that there is timely intervention and impact. The intervention can be defined as weed management, nutrient management, or even pest management. These are the ones that we already know of in our traditional farming, but here the interventions is all about not eradicating but truly just pinpointed method for clearing it off, and the impact it attempts to drive, which becomes the learn and improve mode. The last, of course, is sustainability, our ability to try and reduce the environmental impact, look at how it can help in optimizing production, get more out of the same piece of land. And last but not the least is to look at consuming everything that is being produced, including the waste that we normally leave on the farm. This technology in precision farming, it can be really used for multiple stages across the life cycle that I showed in the previous slide. You could actually get mapping and survey for crop, helping in crop selection, soil suitability, and driving a package of practice which is very customized for this. Modern agronomy in terms of customized crop, region, and season, so that the suitability is more around what best yield and best realization can be drawn out of the soil. Irrigation, resource optimization, not flooding the farm, drip irrigation is probably one of the ones. If clubbed with IoT, I think it can really do wonders in terms of providing enough moisture for the crop whenever during its complete life cycle, of course. Interventions, like I said, nutrient, weed, and pest management, and using it only for the purpose it is intended to, and not necessarily doing an overdoses of everything. Maintenance in the form of health and yield prediction, harvesting for mechanization and aggregation. Today, if a farmer has, in India, I think the average is about 1 hectare per farmer, is how it is being spoken about. If a lot of farmers come together, the aggregation can really yield better results, and could bring in the processing and sale proceeds directly at the farm rather than individual farmers trying to address this separately. Last but not the least, the ability to process, deliver, and do financial settlements as part of the post harvesting is something that can be driven by data. Uh, so, all these four elements on the left, which is data, integration, and ability to improve and driving sustainability, play a major role in how precision farming can make an impact across the complete life cycle of any crop today. What are the advantages for the farmer to go in for technology, for digitization, IoT? I think one of the biggest things that really comes across is truly precision farming, the access to good agronomy and research, innovative cultivation processes, and new crop choices, which can yield much better results during off seasons or during better seasons, is something that can come out of purely data and science. An ability to try and reduce the input cost. A very classic example I normally quote in such forums is that when we use pesticides, we use close to about 2,000 rupees worth of pesticide for rice, let's say in 1 acre. With precision spraying using a drone, one could actually reduce two things. One, the ability of dilution using water. Instead of 100 liters, one could probably use just about 10 or 11 liters. It's about close to 90 liters of saving. The second is the actual input of the pesticide itself goes down by close to anywhere between 25 to 40%. Data also, or should I say, the technology can drive a lower risk and higher volatility. I think insurance companies have started using a lot of these on for parametric insurance. One is able to drive a better risk management, considering that there is a lot of intervention at the farm end also, a higher productivity in terms of yield, and possibly with the connected world that we are today, an access to each and every farmer to a much larger market, leading to a better realization or a higher price. So this is purely a better return on investment for the farmer. For the land, I think as much as we can do and as much as we can say, it is always going to be less. Better land use and soil nutrition management is one of the big tenets. Optimal use of fertilizers rather than typical overdosing and not meeting up any of the residue levels. Reduced pesticide use, water and waste management, more crop per acre in terms of high density, better yield, and last but not the least is truly a farm waste reduction in itself, driving sustainable land use. I put a third block for the aggregator. The reason for this is because everything that is farm fresh is not something that can be consumed by a consumer like us. For the aggregator who buy together a multiple set of farm produce, aggregate it, process it, and probably deliver, the access to a larger supply market is something that can be driven through technology today. Predictable and transparent demand and supply, one could actually project what could be the demand for next season, and accordingly farmers could really subscribe and produce what would be in higher demand. On-time deliveries using all this tech for logistics, I believe. Of course, reduced harmful chemicals in the system and higher quality at lower price. So traceable from the seed to plate is something that I believe technology can really help us in driving for not just the aggregator, but from the farm directly across to uh, the retail consumer. I wanted to introduce Plenti Farms to say that how is it that we have used the technology in our world. We, like I said, we are an ag tech company. Today we are working with close to about 6,300 farmers, mostly in Karnataka. We are currently growing close to about 43,000 acres worth of produce through in the form of rice, chili, pulses, and to a certain extent, specialized crops like gherkins and watermelons. So this is what we do use technology for. and I'll also be showing you the live example of how technology can really become a huge enabler for us. At Plenty Farms, we are a marketplace that tries and brings farmers and wholesalers closer. Very easy to use technology in the form of an app, in the form of data that we have, and drive local support for the farmers on the ground. Uh, our attempt has always been to try and offer better prices ahead of our harvest season, so that there is higher predictability for connecting the demand versus price versus availability. And we truly want to be a very trusted medium for the farmers, so that they are able to list their produce and bring it on. Our marketplace has come on line only as recent as February end, so we are in the early stages of this, but we have been active for the last 3 years trying to build and develop this product line. What sort of a result this drives is, for the market, there is a direct access to farmers and a high and consistent quality can be delivered. For the farmers, access to automation and modern agronomy, possibility of a higher productivity and lower input costs, driving better margins for the farmer, and better and optimal land use, keeping sustainability in view. This is the way we are currently trying to drive our technology. So the light green pieces are on the top, where I've said there is service provider, insurance companies, finance companies, input providers, farm supplies, processors, storage and equipment suppliers. They can continue to manage their part of the service, and can use our platform to reach out to any of the farmers. The intent is to try and drive a higher crop yield, driving on the basis of history, which is where the data comes in. Soil health and crop selection, again, use a lot of data. Autonomous flight paths, digitization has really helped us. We've really been using drone successfully in our regions. Quality management and yield prediction for across the life cycle. uh, as we grow and as we use a lot more of the digital marketplace, demand forecasting and supply transparency will be one of the facets that would be achieved. And last but not the least is the marketplace and the payment settlement pieces. So the way we have been working is, we've been digitizing the farms. We've developed very simple apps. We don't need too much of technology around GIS and satellites. Simple person walking across the farm can solve the problem of digitizing the farm in itself. While the precision in farming engine, or the AI tech that we are currently using, is more around trying to drive soil nutrition, crop history, and a regional characteristic as an input, pest life cycle and weather impact management, we are able to utilize weather data, soil data, crop data, stage of the crop, and try and predict uh, what could be the impact. Also, what is it that the action the farmer can take? So we are currently sending an SMS to the farmer. We're testing also if a live bot can actually call the farmer and tell them what they can do and what they should not do. For the future, of course, there is crop signatures, where crop signatures could really drive how the interventions can truly happen without having to physically go into the farm in itself, and can be done for a large region rather than just for a small farm, using drone survey inputs. IoT inputs for some of the more high value crops. We've seen some very interesting solutions that have come up in the hydroponic space, in the spaces where the crop value itself is very high, like today, sugar cane, chili, or even cotton. Uh, Not all data was always available with us, so we partnered with the US Raichur University of Agricultural Sciences Raichur. We've used their research output to see how is it that we can try and enhance and club it with real life situation or real farm situation on the ground. So all the dark pieces are the ones which we do ourselves. The dark green and the light green, like I said, are independently managed by partners with who provide their own services, who specialize in those services. What is the impact that we are trying to drive here is a lot more for the farmers and community, is more around reduced input cost, up to 20% fertilizer, and probability of a 40% pesticide usage. This is a reduction is interesting if the land size starts growing up. Saving of up to 90% of water using precision farming, precision drone spraying, etc. Increased output in the form of a better grade and trying to use up to 25% of higher yield that can be provided using precision farming methods, technology methods. Soil and ecology, lower residue and soil rejuvenation is one of the big things that we focus on. And with technology, this is easy to drive. It is not as expensive as we all really truly feel. Efficient and better use of all the resources in terms of preservation of soil and ecology, reduce soil degradation. One of the projects that one of the professors was talking to us was about carbon sequestration, leading up to probably desertification in the future. So, the science or technology can truly provide the right intervention so that carbon sequestration can be really improved in the soil locally. For other stakeholders, be it the value chain people who are processing, who are retail, the margins are better. The whole effect is that across the value chain, there is possibility to try and get better margins across from farmer to processor to the retailer, and try and drive consistently high quality, which is dependable, export quality type of a supply, which is traceable, and the a unified sort of a farming method that can be implemented across a region. The output can also be governed in such a way that the quality remains same between any two farms that one picks up as a buyer. So net purely out of experience, way we at Plenti Farms and minus the company even on an agnostic mode, I would say that driving precision farming, use of good data, use of the right level of automation, and using science as the base or the input for each and every at each and every step is something that can truly drive the right impact across all farms. That's largely what I had. I was given 30 minutes. I thought in 25, if I finish, it could really give me some time for any questions that I would want to you would want to take. So this is where we are. We are based in Bangalore, like I said. I'm one of the directors in the company, and Prakash is the other director in the company who can be reached. So that's what I had to present, ma'am. If there are any questions or any part of the open forum, I could take those. Thank you.
Thank you very much, sir, for a wonderful presentation. I will take up the questions now. In the meantime, can you please stop sharing the screen, sir, so that we can see your full video?
Yeah.
Okay. I'll move to the question, sir. The first question is, what are the key challenges that farmers face in adopting new technologies?
I really think there are two major issues when anybody would want to adopt new technology today. One of them is the cost of adopting technology. The, Truly, the cost of adopting technology on a very small farm could really make it look like very unviable. That is one of the big challenges. The second is the tribal knowledge or whatever is the historical knowledge. Our ability to change as a set of people is very less. Primarily, it could be driven by history. It could be driven by so many other inputs. The way I see it is one should try and drive through successful demonstration. So when we were very new in 2023, what we did is we were talking of technology with farmers. We would do all these chopal meetings and temple meetings with farmers. But we realized that whatever we say would probably be not something that they would accept, even if we talk in Kannada, Telugu required. We actually took a lease of farms and we demonstrated that by following our process, we are able to give a much better result. So much so that the BC ratio in some cases was as good as 1.67, which means you put in 100, you get 167 rupees. That is what drove the farmers to say that, okay, if you have a set of agronomy that can really work, you're not going to charge me too much. Yes, I think this is worthwhile to try and take it forward. So net two things: one, ability to absorb technology, and the ability to afford technology are the two big challenges. But successful demonstration really can change the mindset. If not the same season, by next season things would really start looking a lot different.
Okay. How are GPS and GIS technologies being used in agriculture?
Um, I think GPS is a very cheaper cousin of the GIS. GIS in itself is pretty expensive. Sometimes the mapping services for small area is very expensive, I would say. Also, the amount of resolution that one can get out of GIS could really be not as required as we want it. The resolution is largely very less. GPS in itself can really change things a lot, brings in a lot more of accuracy. And with the launch of Navik, our Indian satellites, I think GPS with the 4G or 5G technology is really driving wonders. Data transfer has become easy. Capturing data and immediately transferring it has become very simple. I'll give you a classic example. We used to measure the um, soil conditions. It used to take such a long time. Today we have probe-based soil sensors, which we can do a V or a Z on one of the any farm and quickly drive that result using GPS. GPS, of course, like I said, also we have been using very effectively for preparing maps for the farms in itself. We've developed a very simple technology where a farmer can actually pick the phone and walk around the farm, and we would have mapped everything, including geotagging, physical map. It can be posted on a large map in itself without using too much of science. So sometimes the problem at hand can be addressed with very simple technology, is how I see it. But the adoption of GPS has really started working very well in most farms. You can get real time information on farm status, on how the crop is growing, and also you can relay it across to a quick precision farming engine on the cloud, get your input without any human intervention. One could actually do on the basis of just simple WhatsApp, pick a picture, send it, you'll get a result, you'll get a recommendation. So I think GPS would be the one that would be possible for adoption at the ground level across the country. GIS would be more for larger organizations, probably, who try and drive farming across in a bigger area.
Okay. Can you explain how IoT devices are improving farm monitoring?
So uh, IoT devices today are uh, IoT devices today are being used in farming in the Western world, definitely a lot more than what we see in India. The devices actually measure so many parameters, be it moisture, enthalpy, entropy, if you want. They can measure the temperature, um, uh, and they can actually relay the information, either store it and send it in the day by the end of the day, or probably instantaneously. IoT devices today are being used for very expensive crops today, but it would at some point in time come in for all sorts of crops. Today, greenhouse-based crops are using a lot more of this technology. While they are simple, it takes time to install, collect the data, and set things up, or parameterization. Um, we've seen. I have traveled the world and seen that it is being used for hydroponics because the output is needs to be governed. It's a short cycle crop. You need to intervene very quickly. You can actually measure the moisture or the temperature and start changing what you would want in the field and the farm. IoT adoption is anybody's imagination today, is how I would say it. Today, you want yeah, people would actually set up indoor gardens at home. The small devices can actually check the temperature and switch on a motor or a drip pipe to deliver extra moisture or extra water across the crops. So it's a matter of time when a lot more farmers would start to adopt and start using the IoT devices in itself.
Okay. What are some examples of advanced farm machinery being used today?
I think one of the biggest farm machinery today being used, the harvester, is one of the biggest mechanization, as I would call it. But in for large farms, I think the large harvesters, uh, the segregators in itself, they are such that they can truly just about. We do thrashing when we harvest paddy or wheat. The thrashing itself is done in the machine. For things like potato or tomatoes or vegetables, large farms today, it is even able to do sorting. ripe, not ripe enough, of a particular size, of a different size, spoilt or bad, kick it out. So this sort of machinery, I know, would be expensive for our country, but like I said, it's a matter of time. When there was a time when buying a or having a tractor was a big thing. Today, tractors, you get to see a lot more farmers have it. Then came the idea of harvesters. Harvesters are now being used dime a dozen across every village. Every village or a set of farms, you would find so many harvesters. I think the next step for is partial processing between cleaning versus segregation would definitely be coming in the next 5 to 10 years. Is how I see things.
Okay. What role does technology play in water conservation and efficient irrigation?
I think one of the biggest um, biggest requirement today for technology is to try and drive the amount of water or the amount of fertilizer or the amount of pesticide that should be used. When we look at water in itself, it's a scarce resource. We are a monsoon driven or a canal driven sort of a farming country in itself today. People have been using a lot more of bore wells because of lack of water. But the challenge is, while we've been multiplying the sources, conservation is something that has truly taken a backseat. I think technology can really drive that. For a particular farm, you don't need to flood it. You just need to do drip irrigation. A crop does not need too much of water, except for some crops like rice. But most crops do not need to be watered this much that you really are flooding it. I think technology can start giving the right input. First, basic elementary mechanization and drip-based fertigation is something that really is the first step. The second step is to try and measure water and moisture and across the life cycle and start recommending that you need only this much. You don't need to truly use overuse of it. Third and most important is when we look at new methods of spraying. I continue to quote the drone spraying method. That amount of water that we have been able to conserve with precision spraying is to the tune of 90%. That means against 100 liters, using only 10 liters for this sort of a spray. Um, some part of it is technology, some part of it is education, that we need to conserve water, and I think the results are truly going to be much interesting.
Okay. How affordable and accessible are these machines to small scale farmers?
Like I said, as we adopt a lot more, most of these technologies will start becoming affordable. Today, as a matter of fact, when we register a farm, we don't charge the farmer anything. From registration, digitization of the farm, providing crop recommendation, and of course, the crop calendar. This is free of cost to the farmer. The farmer does not have to pay. He can subscribe and he can get this information free of cost. When we look at the hardware based devices, which could be IoT, which could be more sensors, I think those are a little expensive today. But as we start looking at local production, as we look at a lot more of it being adopted, being bought by farmers and corporates, the price will start coming down. It's a classic example is like an EV battery. At one point in time, it was, I think, about $1,000 per kilowatt. Today, it is at about $300 per kilowatt, just because there are more number of EVs being sold. Similarly, these technologies, when they are being made here locally and being offered in bulk across the market, and not to selective range of farmers or a selective size of farmers, I think these would start becoming very affordable. Very simple. At one point in time, a tractor could be about 10 to 12 lakhs. I'm sure it is similar today, but a small tractor or a mini tractor is now available for 4 lakh rupees. It's just that adoption over a period of 5 years, 6 years, or 10 years starts driving the cost down.
What support systems are available to help farmers adopt new technologies?
Um, there are, I think, there are three places where the farmer can actually get a lot of support. One, the government and its various programs that are aimed for benefit of the farmer, um, be it in the form of subsidy on seed versus pesticide versus fertilizer, or making a drone available for training for helping them. Universities also have been commissioned to try and educate farmers in terms of what do they need to do and where they can access information, what program they can subscribe to depending on crop, region, and support that is being provided by the government, be it central or the state. I think the second big support system today is now there are a lot of farming companies, there are a lot of agri-tech companies. These are the go-to places um, for driving a higher amount of commercialization. So that's sort of a support that okay, next year we need to do a lot more of chili. So some farmers sign up and then they start growing in a particular method. Corporates trying to drive a lot of this is a second place. But I also believe that the third place is the FPOs and the farmer community itself can start driving a lot more of actions and probably derive a lot of results when they come together. Individual farmer probably, unfortunately, does not have much of power, but a group of farmers can start looking like a small company in itself, and that is the power of the farming community to drive and do more.
Okay. Sir, what inspired you to start Plenty Farms, and what is the core mission behind it?
So when so I am an electrical engineer. I've been working in the power sector for about for more than 25 years. But when COVID happened, me and my partner we sat down and thought that except two professions, which is one is a medical profession and the second is a farmer, everybody else could work from home. These two had to simply go down to doctors and nurses had to go down to the hospital to cure people, and farmer had to go down to the farm to grow food so that we all could eat. um, I I think what we thought then is that we should really try and work with farmers to see what we can do for them. Not everything can be commercial, but there should be something that can always be brought to the farmer rather than the farmer going somewhere else. So, with that vision, we started that we'll try and garner a lot of farmer community in itself so that we are able to bring the marketplace to their doorstep. So that was the vision with which we started. Today, while we are a small company today, we are about 20 odd people. We have our head office in Bangalore. I have a small office in Bidar and one small office in Sirwar in Raichur. Like I said, we work with about 6,300 odd farmers today, and that number is growing on a weekly basis. We try and help them on advisory on at least the 43,000 acres that we have. The farmer has a right to follow us or not to follow us, it's okay. But when the produce is available in the future, we intend to buy the produce at the most competitive but beneficial rate for the farmer. That is how we came into existence, and I think we over the last 3 years we've invested a lot in technology, and now we are trying to get the marketplace to the farmer. I think we are trying to achieve some part of that means that we set up for.
Okay, that's very interesting, sir. Can you give us an example of how a specific technology transformed your operations or helped farmers?
Yeah. So when we were looking at a specialized crop like gherkins, we tried to drive the traditional method of growing gherkins in in Raichur area. The Whenever we would try and give guidance, while the crop was meant for us, only we were supposed to buy it under contract farming agreement. But we saw that manually it was getting very difficult. The first season was truly a bit of a washout. We saw to it that the farmer did not lose any money, so we compensated the farmers. But when we went in for the second season in another 3 months' time, we went with a lot of data in terms of what happened, because of what reason something could have been triggered. How do you manage so much with just technology, data, and in-person interventions? So both machine with data and science and man or manpower we deployed in the field. And for the small set of farmers that came in phase two with us, every farmer actually realized a lot of money against each acre. Probably for a 65-day crop, between 25 to 40,000 rupees is what they made, which is pretty good number if you ask me, because without science or without the data that we had, we couldn't have done it. So our learning from the first project and the science that we use for the second, farmers were pretty happy. Now they are all signing up for the next upcoming season now. So I think this is the way we will have to do it and see that it is successfully transferred across to the farmer and the community. uh, growth is always going to happen on the basis of this.
Okay. What kind of government support or policies do you think are essential for agri-tech startups?
I think while uh, while there is a lot of push as an agri-tech startup to do this and to do that, but two three things I think are pretty important. One, of course, an ability to get data. Uh, I'm sure government has a lot of data that they have been capturing for maybe tons of years. That sort of an access, so that truly good solutions in using that data can be provided to the government in itself. The second is I believe that farming is a very noble profession, but we see that uh, we have today. If you go to a retail store, you see food versus health food. I think the government should intervene and say that every food is health food. That is how we grew up. Today, it cannot be on two different counters. Government's promotion of products like millets or jowar, bajra, which are very native to Karnataka. I think that promotion is something that they'll have to do a lot more. I attended a conference a few months back, the trade fair. The chief minister and the deputy chief minister were there. This was one of the big things that everybody proposed. That technology is one aspect. Ability to drive that technology or ensure that it can reach the last farmer is the second. Enable farmers to understand that local crops are the ones that are truly getting you better results if required. So that sort of a policy, and maybe some level of intervention in the form of technology investment by the government itself could really change a lot of things.
Okay. What is your opinion on the future of contract farming and private participation in agriculture?
Uh, I think the future is going to become contract farming to a larger extent. Today, contract farming is a very small portion of all farming that happens in India. But going forward, I would not be surprised that in the next 20 odd years, it could be 25% or even 30%. The reason for this is that the farmer would start getting a customer before they sow the seed. That is one. So he's assured of his returns from the day one by the time he's just tilling the soil. For corporates, the benefit is, of course, they know where what is being grown, what has been the process, and what is it that they can get for that sort of a produce. This sort of a participation between private versus farmers is something that we see a lot more in the future. Uh, while there is a lot of today support by the corporates to try and do more of organic farming, but the traditional residue-free farming or traditional farming in itself will also be something that will grow a lot more as we go forward. And for that, the best operationalizing method is a contract agreement or contract farming. You can drive better quality, you can drive better output, you can actually see to it that there is traceability, meet all the MRL levels for a India or a export market, and a higher realization for the farmer as it is.
Okay. What advice would you give to young agri entrepreneurs or students interested in this field, sir?
Uh, to students, I believe that they need to be committed, uh, and they should believe that farming is about as competitive a profession as any other IT or probably electrical engineering or a doctor. That is one I would say. The second is for agri tech. I think this is more of a very long term commitment that one has to make. One can't make money like any other IT startup or a SaaS based startup in 2 to 3 years. I think, and I draw parallel from my energy business that I used to run. The power business was such that anybody who committed to the power business, making equipment or solutions, it was for multiple years. It was not to make money in the first year. I think farming is also such. All ag tech companies can really focus on this. We don't have to solve everything at the same go. We pick a small piece and say, this is what I'm going to solve. And this is the way it will be beneficial for everybody in the life cycle. I think that is what we should address.
Okay. What has been your most challenging moment as a founder and how did you overcome it?
convincing farmers is very, very challenging now. To change is very challenging because they have been the people who suffered the most. So they have the right to their resistance. But I believe that it's a matter of time that things could change. But some of the conversations with farmers once the crop starts growing is very, very, sometimes it's very difficult, very, very difficult.
Okay. Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we'd like to thank Mr. Siva Subramanyam Mantha for the talk and for answering the question. This meeting is now being closed.
Thank you for having me over, ma'am. Really much
Most
appreciated.
welcome, sir.
Thank you.
Yeah.